class, this is Dr. Karsten, and today we are doing Lesson 20 from Module 5, Grade 4, EngageNY Math. And in today's lesson, we are going to continue adding fractions, but in today's lesson, our fractions are going to have different units or different denominators. And that presents a little bit of a problem because you cannot just go and add 1/3 and 1/6. You need to have your units, your denominators, be the same if you want to add. For adding and subtracting, you need to have your units be the same. So what we are going to work on today is we're going to work on modeling a couple different ways on how to get these units to be the same, how to get your denominators to be the same. We're going to use tape diagrams, we are going to use a number line, and we are also going to be actually doing this mathematically because I know that for some of you, that's going to work a whole lot better, that you have a much better grasp on how to do this mathematically than how to draw it. When you're drawing it, it throws you off. So don't worry. So if you feel a little overwhelmed at first, remember it's going to take a few problems for this to make a lot of sense. And again, don't get stressed out if in the beginning it's a little tricky because we're doing it in a way that you're not comfortable with. I promise you one of the ways will work for you. Okay, so let's get going. So here what you see is I have 1/3 and 1/6. And what I did was I actually went ahead already and I drew tape diagrams for these and shaded them in. So if you take a look over here, let me just point out a few little things for you. First of all, I labeled that this was my tape diagram for 1/3. I labeled that this is my tape diagram for 1/6. For this one, you can see that my denominator is 3, so I have 3 equal-sized pieces or parts. And here you can see that I shaded in one of them because my numerator is 1. Down here, I have 1/6, so I have 1, 2, 3, 4, 5, 6 parts, and one of them is shaded in for that numerator. So if I want to add these in, I'm going to have to turn one of these fractions, I'm going to have to change its denominator. I'm going to have to decompose it. Now, luckily, in today's lesson, all of the pairs of fractions that we are adding are actually going to be related. So what that means is that one of them will be a multiple of the other, and I'm just talking about the denominators. Now, if I look at 3 and 6, I want to remind you that 3 is a smaller number, but 1/3 is a larger fraction. And that's because here each piece is much bigger because I'm only dividing the whole into 3 pieces. Whereas when I'm dealing with 6, I divided the whole thing up into 6 pieces. So each piece is a whole lot smaller. Each piece is a whole lot smaller when you have 6. But I'm going to be talking about the smaller number being the 3, and that 6 is a multiple of the smaller number. So for example, here I know that 3 times 2 gets me to 6, or 6 divided by 3 gives me 2. We've done a lot of that where you've been working on how to decompose, or also working on comparing the fractions, and we have actually already done a lot of this where we've compared fractions and gotten common units or common denominators. Okay, so back to this problem. So one way that I could look at this is I can say, hey, look, my 1/3 here, I can see that 1/3 is the same size as 2/6. Let's look at this third right here. If you look at this 1/3, it is the same size as these 2/6. So one thing that I could go ahead and do is I can very carefully go and decompose all these thirds into 6 by cutting them in half on this tape diagram. And now what we see is that 1/3 is actually equivalent to 2/6. So let me write that. So I'm going to write that underneath here, that this 1/3 becomes 2/6. This I'm just going to leave as 1/6. So now I have what I need. My units are the same. I have common denominators. So 2/6 plus 1/6. Now I hope all of you are telling me, well, 2 of this size pieces plus 1 of those size pieces is going to I'm going to write it under here, is going to give me 3 of those sized pieces. I'm writing it under here because I don't want to get too close to this stuff. Now here's the thing. When you are using this technique, you have to be really, really careful to line everything up really carefully. What you can see here is that these are lined up at the ends, and over here this end is lined up. And the other thing I hope you're noticing is that my thirds are lined up really nicely on top of those where every other sixth. If you are not good at this, that is my concern. You're going to have two other ways to do this. So I do want you to be able to see this and draw this. But I also want to understand that, this might not be the best way for you, but you should still know how to do it. So again, we took 1/3, we decomposed it into sixths. So now we had 2/6, and then we were able to add these 2/6 plus this 1/6. The 2/6 plus 1/6 is 3/6. Let's do another one like this. Let's go ahead and take another pair of fractions that we then need to decompose one of them so that we have matching units so we can add them. So let's take 1/2 plus 1/8. So again, what I'm seeing is that my two units, or my two denominators, are different. They're not the same. And so I can't just go and add them. I can't just say 1/2 plus 1/8 because I need to have common units. So what I also see is that 8 is a multiple of 2. I know that 2 times 4 is 8. And again, we have that little sneaky thing that we like to do when we're working with that. And let me go ahead and I'm just going to do that over here. Remember, we can say like, 2, 4, 6, 8. I can write my multiples. And now I know that there are 4, because 1, 2, 3, 4. There are 4 2's in 8, or 2 times 4 is going to be equal to 8. I'm just reminding you of this little shortcut that we have because we're going to be using that in a minute. Okay. So back to though doing this using a tape diagram. So I have 1/2 and I have 1/8, and again what I figured out is that I'm going to have to decompose each one of these halves into by 4 into 4 pieces to get me 8ths. So let's go ahead and model this with a tape diagram. And again, I have to really be careful that I line up my tape diagrams carefully, that they're about the same size and that their ends match up. I also have to label them. So here I'm going to do 1/2 and here I'm going to do 1/8. And the first thing I'm going to do is I'm going to try and cut this nice and neatly into halves because my denominator is 2, so I cut it into 2 pieces. And then I'm going to shade in one of those pieces because my numerator is a 1. So there we go. Now let's do 1/8. And what you'll see is when I'm doing this, I actually like to start right here. Since 8 is an even number, I can start right in the middle and decompose it into halves first. And then I always cut it into fourths. And then I like to cut it into eighths. And that's the way that I try and get as even-sized pieces as I can. Okay, so let's see. I have 1, 2, 3, 4, 5, 6, 7, 8 pieces. So that's my denominator. And then I need to shade in one of them for my numerator. Okay, so you can see I can't just go adding these, that's not going to work. So what I need to do is I need to decompose my half into eighths. And because we did this drawing so carefully, let's just look over here. I can see that half is equal to 1, 2, 3, 4 eighths. So now what I can do is I can decompose this half into eighths. And I can do that by drawing the dotted lines to show that I'm decomposing it. And now what you can see is that 1/2 is equal to 4 eighths. So now what I'm going to go ahead and do is I'm going to add, instead of adding 1/2, I'm going to turn that into 4 eighths. And I can just say 4 eighths plus 1/8 is equal to, so we have 4 of those size pieces plus 1 of those pieces gives me 5 of those pieces. And I can see that here, 1, 2, 3, 4, 5. Okay, so again, what we did was we took the 1/2 and we decomposed it to make units that would match up with 1/8. We turned it into eighths. And I actually could have gone ahead and decomposed the entire thing to show that we now have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now if you are really awesome at doing this, you can do it this way. I'm going to show the mathematical way to do this because I know that for some of you, that's just going to make so much more sense. So I'm going to do that down here. Don't let this confuse you, but you should be pretty good at this because we were working on finding common denominators before, or common units. So if I have 1/2 and I have 1/8, and I want to turn that 2 into eighths, right? So that I can add these together. Remember what we did before? We worked with the multiples and we said, okay, 2, and then we said 4 and 6 and 8. So I know that 2 times 4 will get me to this 8 because there's 1, 2, 3, 4 2's in 8. So I know that 2 times 4 is 8. Hold on to that again on the side. Remember that. I want to turn this into eighths. Another way that we did this was like this. Do you remember doing this? So here we go. I have 1/2. I want to turn it into eighths so that I can add them. 2 times what number will get me to 8? 4. And we know that because of what we did over here. We also could have said 8 divided by 2 is going to give me that missing number. And we've done this a whole bunch of times. You should be really good at this by now. And then 1 times 4, because whatever we do in the denominator, we have to do in the numerator, because 4 over 4 is just 1. And then 1 times 4 is 4. And now what you can see is I decomposed 1/2 into eighths, but I did it using math instead of using the tape diagram. I am okay if you want to do it this way, as long as you show me what you did. So now I can take my 4/8 and my 1/8 and I can add them. So 4/8 plus 1/8 is 5/8. So we got the same answer doing it 2 different ways. So let's do another problem, and this one's going to be very similar to these. We're going to do 2 more problems before we get into the practice set, the problem set. So let's do something a little different. Instead of having unit fractions, let's have numerators that are a little different. Oh, let me just bring this a little bit further down into our area. So let's say that I wanted to add 2/3 plus 3/12. So first I'm going to use a tape diagram to model decomposing, and then I'm going to do it the mathematical way. You can do it either way. So here we go. So first I want to model 2/3 and I want to model the 12ths. So I need a kind of long tape diagram because I am going all the way up to 12ths, and I need 2 of them. And again, if you are doing this with a tape diagram, you need to draw it nice and careful. Okay, or carefully. All right, so I have my 2/3 and my 3/12. So let me start with my 2/3. So I'm going to go ahead and do my best to try and cut this into even thirds. And then I have to shade in 2 of them this time because my numerator is 2. So again, I cut it into 3 pieces because my denominator is a 3, so 1, 2, 3. And now for my numerator, I'm going to go ahead and shade in 2 of them. Now for my for my bottom fraction here, instead of cutting it up into thirds, I need to cut it up into 12ths. So I'm going to do my best to make them nice and even. And see, now this is where I get concerned that some of you guys are not the best at cutting these quite so evenly. I'm just going to kind of emphasize these ones that align themselves right there. Okay, so now that I cut that up, I need to color in 3 of them to show that I have 3 pieces. That's my numerator. It says how many of the pieces we actually have or should be shading in. So now for me to be able to add thirds and 12ths, I need to decompose those thirds into 12ths. And what you should be seeing here is that, and let's just look at this empty one, that 1/3 is the same as 1, 2, 3, 4 12ths. So let me go ahead and make these match up with these by cutting them up in the same spots as where those 12ths are. Now again, if you're confused, we're going to do it the mathematical way in a second, so don't get stressed out about this, because I am going to model every single one of these. And I'm going to go ahead and cut this empty one just so I can really show you that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of those in there, just like we have in the bottom fraction. So now what you should be seeing is that our new denominator is 12, so I'm going to go ahead and write that down here. And that our new numerator is 1, 2, 3, 4, 5, 6, 7, 8. So now we get to add 8 12ths plus 3 12ths. And the 3 12ths came from the bottom fraction. And then I could just actually count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Or we know that 8 of those size pieces plus 3 of those size pieces is going to give me 11 of those size pieces. Okay, so that was using a tape diagram. Let's do it mathematically now. Let's do it by decomposing using multiplication. So I have 2/3 and I have 8/12 and I want to add them. So the way that I'm going to do that is I know that I want to decompose my thirds into 12ths. So we're going to say that 2/3, remember we always write down the fraction that we started with. Then since I'm turning thirds into 12ths, I know I'm multiplying, I'm decomposing. And I always want to show what I want to turn it into. So I want to turn these thirds into 12ths. Okay, so how am I going to do that? Well, again, I can use multiples, or I could say that 3 times some number is equal to 12. Or again, I can take the inverse and say 12 divided by 3 gives me that number. And if you do 12 divided by 3, you should get 4, which means that's the number we're looking for. But again, I want to kind of keep you thinking about those multiples, and that I could have done multiples of 3, 6, 9, 12. This is going to play into a future lesson. So that's really why I want to emphasize that, that you can use multiples right now. Okay. So again, we went ahead and we said 3 times what number is 12, or 12 divided by 3 will give me that number, and we figured out that that number is 4, and whatever we do in the denominator, we have to do in the numerator. So now we can just go ahead and say 2 times 4 is 8, and we got 8/12. And that's exactly what we got when we were working up here. When we converted, or when we decomposed 2/3, we got 8/12. So it's the same exact thing. Okay, so now we have our 8/12, and I was looking at this, I'm like, why do I have 8 here? This should be a 3. Sorry, guys. It was 2/3 plus 3/12. I was just looking at the number up there. Okay, so back to this, though. So I have 2/3 and 3/12, so now I can actually add these. So I'm going to have, but instead of 2/3, let's write 8/12. So we have 8/12 plus 3/12. And then we get 8 plus 3 is 11, so we have 11/12. So we got the same answer both times. Okay, so let's just really quick recap. We can use a tape diagram, or we know how to decompose through multiplication. So you can use either way. Let me do one more example for you, but for this one, we're actually going to use a number line. And just in case I need a little extra paper, because again, you know me and I want to show it to you mathematically, I'm going to go to a fresh piece. So let's go ahead, and we are this time going to add 1/6 plus 3/12. So this time I want to do it a little differently. So what we're going to do is we're going to draw a number line, and that number line is going to have to be partitioned into both 6th and 12th. Now, right now, some of you guys might be saying, well, how do I know what the relationship between those is? How am I going to know what to do? And again, we can always turn back to that math if you get a little confused. I'm hoping that a lot of you are at this point going to say, well, I know that to turn 6 into 12, I have to cut each one of those pieces in half, because 12 is twice as much as 6. And if you just went, what? Don't worry, it's okay. We're fine. Okay, so let's go ahead and let's try drawing this number line, and then I'm going to explain that a little bit more, what I was just saying, using math. So we have our number line, and I'm going to first put in my 0, and remember this would be 0 or 0/6 or 0/12, and then over here I'm going to have 1, and that 1 would also be equal to 6/6 or 12/12. When our numerator and denominator match, then we know we have 1. So the first thing I want to do is I want to partition this off, or cut this up, into 6th. So let me go ahead and do that, and I'm going to try and do it as carefully as I can. I'm trying to get them as even as I possibly can. I want them to look really good. So I think that's okay. And what you're seeing here is that I have 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. So now what I want to do, though, is I want to put in those 12ths. And again, if you don't know how to do that, remember that what we can always say to ourselves is 6 times what number gets us to 12, or inversely, 12 divided by 6 will give us that number, and it's 2. When you get that 2, what you now know is that I need to cut each one of those up into 2 pieces. Now again, we're going to do it mathematically, so if this is like a little it's okay. But I do want you to get a better feel for this, so we are going to do it a whole bunch of different ways. So now I'm going to use a different colored marker just to make this really clear. When you go ahead and you turn these into 12ths by cutting each one up into 2 pieces, you're going to use a dotted line. Now you probably wouldn't have a different color, but that's fine. So I'm going to go ahead and do that. All right, almost done. And then let's check to see if that worked. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it sure did. We have 12 parts. So each one of those is 1/12. So now we can actually just go ahead and add these together. And the way that I'm going to do it is first I'm going to go ahead and I'm going to put my 6th onto the number line. So remember, these are our 6th. And I'm going to go ahead and I'm going to put my 1/6 here. I want to show it. So that's 1/6. And then, let me first show that I added 1/6. I went from 0 to 1/6. And now what I want to do is I want to add 3/12 to that. Remember, the little hops are my 12s. So what I'm doing is I'm going 1, 2, 3. So now let's model that with an arrow. And what we just did was we added 3/12. And now what we do is we can figure out it's going to be 1, 2, 3, 4, 5 12s. I was counting the little hops. Oh, that's so bad that I just wrote that. I am so sorry. 5 12s. Okay. My pen's going faster than my brain, I guess. Okay, and it's 5 12s because these are cut up into 12 pieces, and I hopped over 5 of them. So again, 1/6 plus 3/12 is going to give me 5 12s. All right, so if this number line is confusing you, I do hope that you're starting to see that that like 6ths are twice as large as 12ths, and that's because to get to 12 I multiply by 6, or I can divide 12 by 2 to, multiply times 2 to get to 12. I hope you're starting to get a feel for these things, even when I say them slightly backwards. But let's do this problem mathematically also, because again, for I think some of you, it's really just going to make so much more sense. So if I wanted to add 1/6 and 3/12, and I wanted to get common units, if I wanted my units to be the same, or my denominators to be the same, I'm going to have to turn one of them into the other. I'm going to have to decompose one of them. And the one I'm going to decompose is I'm going to decompose my 6th, which are larger pieces. I'm going to cut them into the smaller pieces, into the 12s. So I want to model that using math. So again, we know we're turning the 6th into 12ths. So I'm going to put a 12 here because I want to turn my 6 into 12s. Now I have to figure out 6 times what is going to give me 12, or 12 divided by 6 is going to give me that number. Well, 12 divided by 6 is 2. So I know that number is 2. So I'm going to put a 2 here. 6 times 2 is 12. Whatever I do in the denominator, I do in the numerator. 1 times 2 is 2. So now what I know is that 1/6 is equal to 2 12ths. So another way to say that is to say 3 12ths plus 2 12ths, because what I'm doing is I'm adding these two. Remember, that was the original equation or problem. So where was I? I have my 2 12ths, I have my 3 12ths. What do I get? I get 5 12ths. Nice and easy. Okay, so whichever way works for you is the way I want you to do the problems in the problem set. So I'm not going to do a whole bunch in the problem set, but I am going to just give you a little taste of it just to be really clear. So I want to show you how the 2 pages are different to start off with by reading the instructions with you. So again, we're in lesson 20 problem set. So here it says, use a tape diagram to represent each addend. The addends are the 2 fractions that we're adding together. decompose one of the tape diagrams to make like units. Then write the complete number sentence. Part A is partially completed. And remember, we don't look at that because I feel like it throws us off too much. So that is a really different instruction than what you see in the second one. And what's different is here, they tell you to model it with a tape diagram, whereas in this one, it says estimate to determine if the sum is between 0 and 1 or 1 and 2. So we are going to have some that are going to be larger than 2. Draw a number line to model the addition, then write a complete number sentence. So again, here, the other thing that's different is that we're doing a number line. So here, it could be between 0 and 1, or it could be a fraction greater than 1. It could be our solution, our sum. And then we want to do it with a number line. What I am telling you right now is that I am okay with you choosing which way you do it. You can either use a tape diagram, or use a number line, or you can do it mathematically. And that's what's really important to me, is that you have that choice. So I'm going to just quick model 2 of them, and then you're going to be off to the races on your own. So I am going to do this one using a tape diagram and doing it mathematically, just because I think that it's beneficial. So here I have 1/4 plus 1/12. So I'm going to try not to make things too big. But first I need to model my 1/4, and I need to model my 1/12. And again, you have to line these up really carefully. And then I'm going to go ahead and partition this off. So I partitioned my 1/4. I partitioned that one into 4 pieces because my denominator is 4, my numerator is 1. So I'm going to color in one of them. Then for 1/12, I'm going to have to very carefully do the same thing, except for now, oh no, I did it right, sorry. I need to have 12 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I did it, and now I just have to color in one of those. So hopefully what you're seeing is that 1/4 is equivalent to 3/12, and you should see that from your drawing. But if you don't, or if it doesn't make sense, that's where the math is going to come in really handy. But now I can decompose my 4th into 12ths. Like I said, I can see that I have to cut this into 3 pieces based on this. So I'm going to very carefully draw in my dotted lines, and I'm going to do it for all of them for us. You don't actually have to, but I think that it's helpful when you do it. It really reinforces what you're doing. Okay, so now what you should see is that 1/4 is equivalent to 3/12. So I could rewrite this 1/4 as 3/12. And I could say 3/12 plus 1/12 is equal to 4/12. I'm sorry, I'm a little squished, but that's because I'm trying to save room down here to do it the other way. Okay, so that's one way that I could do it, is I could use the tape diagram. Now I'm going to do it mathematically. So if I want to add 1, I'm going to just circle this because that's our problem, 1/4 plus 1/12. I know that I want to decompose my 4th into 12ths because it would be really hard to take 1/12 and turn it into 4ths. So I want to decompose the 4ths into 12ths. So remember, first we write down what we're doing, and I'm going to stick in blue for now just to keep these separated. So I have 1/4. I want to write down my original equation, and then I want to show what I'm turning my denominator into. I want to turn that 4th, I want to decompose it into 12ths. So I'm going to be multiplying. So 4 times some number gives me 12, or 12 divided by 4 gives me that number, which is 3. So now I know that I'm using 3. So I put a 3 in the denominator, and whatever I do to the denominator, I have to do the numerator, because if I multiply by 3 over 3, it's really just multiplying by 1, and it's not really changing the size of things as far as the total amount that we have. Alright, so 4 times 3 is 12, and 1 times 3 is 3. So what did we just find out? That we got the same result as we got up here, that 1/4 is equal to 3/12. And now I could just write that all down and add it up again. So 3/12 plus 1/12, 1/12. 1/12 is equal to 4/12. So all we did was we added them after we converted this, decomposed 1/4 into 12ths. And that's our answer again. So we got the same answer 2 times, doing it 2 different ways. Okay, so I'm going to leave this page for you. You're going to do these problems. And then I just want to jump onto the second page really quickly and kind of take a look at this second page and do one of the examples where it does go greater than 1. So, let's go big and let's do F. So let's do that. Let's model that one. And again, I'm going to do it in 2 different ways. I'm going to do it the way they suggest, which is using a number line. But then the other thing that I'm going to go ahead and do is I am going to do it mathematically. So let's start by doing it using the number line. So I need a nice long number line. And now again, the thing that they said was that first you have to estimate, is this going to be between 0 and 1, or is it going to be a fraction greater than 1? And what I'm thinking is that since 6/5 by itself is already greater than 1, because 6 is greater than 5, then I definitely know that this is way, way hands down going to be a fraction greater than 1. Now, let me say this. If I were looking at the question over here and I saw 3/4 and I saw 6/8, for that one, there isn't that obvious thing. So when in doubt, go ahead and map it out to be a fraction greater than 1. Go ahead and go from 0 to 2 when you're in doubt. But let me just say here that this is definitely going to be a fraction greater than 1 because I have 3/4 and I have 6/8 and they're actually both greater than a half. And so you know that when you add them, you're going to get something greater than 1. But again, if you don't see that, be safe and do what I'm doing over here when you're setting it up. So what I'm going to do is I'm going to go ahead and mark off where my 0 is, I'm going to mark off where my 1 is, and I'm going to mark off where my 2 is. And then the first thing I'm going to do is I'm going to partition this off into fifths. And fifths are those interesting ones where it doesn't divide evenly in half. So I'm still doing a few more. Here we go. So I'm going to really make my 1 and my 2 and my 0 stand out. And what you can see now is that I have 1, 2, 3, 4, 5. So 5 pieces make up one whole. And then I have another 1, 2, 3, 4, 5 pieces that make up one whole. Now the next thing that I have to do is I have to decompose these into tenths, or I have to show where the tenths would go. I'm going to partition this into tenths. Again, I'm going to use a different color for this. And I'm going to use a dotted line when I'm going for these smaller pieces. I'm doing my best. And what I know is that since 10 is 2 times the size of 5, or 5 times 2 is 10, I need to split these into 2 pieces. That's something we've been saying kind of for a while. Okay, so now you can see that each one of these has 10 little pieces. Okay, or parts. So I didn't really leave a lot of room for my arrows. I'm sorry, I'm still trying to leave room for the math here. But let's go ahead and let's start. I like to start with the larger number, so I'm going to start with 6/5. So 6/5 is going to be 1, 2, 3, 4, 5/5, 6/5. So 6/5 is right there. So I'm going to go ahead and I'm going to squeeze in an arrow and point it at that 6/5. I have to write that I just added 6/5 onto this number line. So now what I have to do is I have to go another 4 tenths because we added the 6/5. Now we have to add the 4 tenths. So we're going to go 1, 2, 3, 4. We're going to make an arrow going to here. And then we're going to show that we just added 4 tenths onto this. 1, 2, 3, 4. And now I can figure out what the whole thing is. I can start by going 1. And then since it's landing on these lines, on the fifths, I can just count by fifths. So I have 1 and 1, 2, 3 fifths. So that would be 1 and 3 fifths. Or another way of writing that would be 1 and 6 tenths. Because I could go to 1 and go 1, 2, 3, 4, 5, 6. Either is correct, although I would rather have that one, but either is totally